Rational exponents for any real number b and any positive number n, b over 1 over n equals the nth root of b. So what that's saying is the index number in our radical, the index number of our radical will be the denominator of the exponent, okay? So if you had the square root of 2, if you put it in exponential form, okay, that's the vocabulary that will be used. Square root of 2 is in radical form. If I was to put it into exponential form, that would be 2 to the 1/2 power. That comes from, we have our 2 inside the radical. 2 has an understood exponent of 1. That's the numerator. And then the denominator will be that index number, okay? So the square root of 2 is the same thing as 2 to the 1/2 power. So example 1, 28 to the 1/2 power, that's the square root of 28. Now we can simplify that to 7 and 4. 4 is a perfect square, so we can take out a 2. We have a 7 left inside the radical, okay? We could also write that as 2 times 7 to the 1/2 power, okay? It's the same thing. Example 2, that is the same thing as the cube root of -8 over the cube root of -125. What's the cube root of -8? -2. What's the cube root of -125? -5. Good. All right, next section, we'll write, if it's in exponential form, you're putting it in radical form. All right, radical form, exponential form. So, number 1, what would be the radical form there?
7th root of 11.
Good. 7th root of 11. Good. Yep, we're just putting it in radical form. Number 2, what would that be in radical form? Cube root of 15. All right. What would number 3 be?
3 times the square root of 30, or 300. Oops.
Let's say that again.
3 times the square root of 300.
No, the 3 will be the exponent inside the radical. Square root is right. Square root of 300. And then 300 will have an exponent of 3. Okay? All right. Now, in the last class, someone was like, we can simplify that. We can simplify that. Anyone know what we could simplify that to?
300 to the 2nd power.
Close. All right. We have 300 cubed. That's 3 300s, right?
Oh, just 300.
So
300, right?
square root 2 of a kind to take one out. So we could take out 2 300, or we could take out a 300. I accidentally wrote 3,000. You can take out a 300. You'd have a 300 left inside the radical. Now, it wasn't asking you to do that. Just they wanted to take it to the next level. So you could also write that as 300 times 300 to 1/2 power. Again, wasn't asking you to do that. Just trying to show you everything there, right? So if I don't show you everything, then Royce is going to be mad at me. No, I'm just joking. All right. Number 4, what would that be in exponential form?
47 to the 1/2 power.
Good. 47 to the 1/2 power. All right, so 5's a little different. We haven't been over one like that. All right, you give you give the coefficient and each variable exponents in exponential form. So that will be 3 to the 1/3. A to the what? 5/3. So we'll come back to that, what you said, Emery. And then B would be to the 2/3. Good. So Emery said 1 and what? 2/3?
Sure.
What'd you say 5/3 was?
I don't. Whatever came out of my mouth, I don't know.
All right. So she said it was 1 and 2/3, right? So what that means is we could actually take an A out, right? That would simplify to where we could take an A out, and you'd have 2/3 left in the radical there. Here, I wrote that wrong.
It'd be 2A.
I wrote that wrong. Don't worry about how I wrote that.
Yeah, I mean, yeah.
I wrote that wrong.
I just
Move on to 6. I wrote that wrong. Shh. All right, number 6. How would we write that in exponential form?
162 to the 1/4 power times p to the 5/5.
Good. Very good.
2p to the 1/4 power.
So, but I want to show you something here. All right, so 162 is 81 times 2, right? What's the 4th root of 81?
3.
Good.
Interesting.
All right. So you could simplify that to 3p. 4 goes into 5 one time, so you could take out a p. You have a p left in the radical. So technically you'd simplify that to 3 times p times 2 to the 1/4, p to the 1/4. Okay?
You have to simplify it.
I'll let you know when you have to simplify. All right, next part here we have operations. Okay? If you look at example 1 right here, we have y to the 2/3 times y to the 3/8. What do we do with exponents when we multiply variables?
Add them together.
We add them, right? So you're going to do the same thing here, even though they're fractions, but your fraction rules come into play. How do you add fractions? You need a common
Denominator.
denominator. So what would be the common denominator here?
24.
24.
We're on the example.
Yeah, we're on the example. All right, so 2/3 would be 16 over 24. 3/8 would be 9 over 24. So you're going to do 16 over 24 plus 9 over 24, which that would give us 25 over 24. Okay. I'm fine with you leaving it like that. Okay. Fine with you leaving it like that. That could also be written as y times y to the 1 over 24 power. Okay. That would be it simplified.
Could you not say 2y?
No, it's not 2y. Because again, when we multiply variables, what do we do to the exponents? We add them. And so the coefficients are 1. So it'd still be 1. All right, example 2, simplifying. All right, pay attention here. All right, what's the square root of 140? I know this is not a square root. What's the square root of 144? 12. So 144 is also 12 squared, right? All right. So if I took the 4th root of 12 squared and gave it rational exponents, what would that be? Or I could put it in exponential form. What would it be? 12 to the 2/4 power. What's 2/4? 1/2. So the 4th root of 144 is technically 12 to the 1/2 power. Isn't that nice?
So it's just the square root
Yep,
of, wow.
square root of 12. Now, if you simplified it all the way, 4 of a kind to take one out, take out a 2, you'd have 9 left inside the radical. With the x's, 4 goes into x one time, leaves you with x squared inside the radical, okay? Which that would simplify to, oh, I guess I didn't simplify. That would be 2 times x times 9 to the 1/4 times x to the 1/2. Now, 9 to the 1/4 would actually simplify to 3 to the 1/2 power. Times x to the 1/2. Because 9 is 3 squared, right? Here, I'm going to write that up here. 9 is 3 squared. So that would make that 3 to the 2/4, which is 3 to the 1/2 power. So all that to say, you still get to that same point at the end when you simplify, whether you do it at the beginning and you have 12 to the 1/2 power, which that would simplify down to 3 to the 1/2. Okay, you'd be able to take out a 2 and you'd have 3 left inside the radical, or you could do it at the end. Okay, it's always easier to simplify at the beginning. Okay, now again, I'm taking this deeper than I would with the regulars. Okay, so just letting you know that there. Understand that that is going a little bit deeper. Okay. All right, let's jump to number 1. Multiplying variables. What do we do to the exponents?
Add them.
So what would that be?
X
Which is
Squared.
good. All right, number 2, power to a power. What do we do with exponents when we have power to a power?
Multiply.
Multiply. So that'll be y. What's 2 times 3? What's 3 times 4? So what's that simplify to? Y to the 1/2. Good. All right. Do 3 and 4. Number 3, what'd you get?
X to the 41, 24.
Good.
Times x to the 6th.
Nice, Gavin. Nice, Gavin.
No, I'm good.
All right, number 4, what'd you get?
N to the 12, 20 seriously.
Good. All right, number 5. Okay, we're dividing variables. So what do we do with exponents when we divide variables? Subtract. So that's going to be 1 minus 1/3. So to get a common denominator, what will that 1 be? Nope. 3/3. Good. So 3/3. Oh, Gavin gave the answer. 3/3 minus 1/3 gives us 2/3 there. P to the 2/3. Do number 6. All right, good. The answer, you have 1/2 minus 1/3. The answer is 1/6. All right, number 1. It's the same thing as the square root of 5 over the square root of 2x. So we need to multiply by the square root of 2x to make the denominator a perfect square, which gives us the square root of 10x over 2x.
You know what? We were close. We were so close.
Number 2, square root of 18 times m to the 5th, p to the 6th. Well, if we simplified 18, 9 and 2, so we can take out a 3. We got a 2 left inside the radical. All right, the index number is 2. 2 goes into 5 twice. remainder of 1. And then 2 goes into 6 3 times. And that is actually the application of the even, odd rule.
Yeah.
We did it.
Girl power.
Girl power all the way. 3. We got 4 square root of 12 minus square root of 18 plus
We were cooking on this one.
square root of 108 plus 7 times the square root of 72. So 12, I would do 4 and 3. Can take out a 2. So it gives me 8 root 3.
Yeah.
I would do 9 and 2. Can take out a 3. That'd be minus 3 square root of 2. Here, I would do... What's 108 divided by 3?
36.
Perfect.
Yes.
36 and 3. 36 perfect square. It's plus 6 root 3. Then 72. I would do 36 and 2.
Yep.
Perfect square. 6 times 7 gives me 42 root 2. And then I can combine like terms. That'll give me 14 square root of 3. And then plus 39 square root of 2.
We're just that good. Oh yeah, we are so good.
All right, number 4. We got square root of 5 minus square root of 7 times square root of 5 minus
Don't worry about it.
square root of 7.
Oh, we
I did not do that.
First would be 5.
I did 5 minutes of it.
Outer, negative square root of 35. Inner, minus square root of 35. Last, plus 7. So that would be 12 minus 2 square root of 35.
What time is it?
We got 7 minus square root of 5 times 3 plus 2 square root of 5. Shh. First, 21. Outer, 14 square root of 5. Inner, minus 3 square root of 5. Last, that will be minus 2 times 5. Because that'll be the square root of 25, which is 5. So we got 21 plus 11 root 5 minus 10. So we got 11 plus 11 square root of 5.
Yep, we cooked on that one.
Number 6, what do we need to multiply by?
The reciprocal, or the whatever it's called.
The conjugate.
That, the conjugate. We did it though, so
Same
it's
difference.
fine.
All right, so
We did it, Royce.
first
E.
gives me 8. Outer, minus 2 square root 6. Shh. Inner, minus 4 square root 6. Last, that will be plus 6 over first, 16. Outer, negative 4 root 6. Inner, plus 4 root 6. And then last, that will be minus 6. So, cancels, and that will give me 14 minus 6 square root of 6 over 16 minus 6 is 10. And then that simplifies to 7 minus 3 square root 6 over 5 because 14, 6, and 10 are all divisible by 2.
So you could say we're just.
All right.
But we didn't get anywhere past.
Yeah.
We didn't go past it.
X to the 5/8 in radical form would be the 8th root of x to the 5th.
Yep. That's where we ended.
Yeah, that's where we ended.
8
Let's just keep going.
5th root of 32 z cubed. Well, 32 is a perfect 5th root. What is it? 2 times. And then that would be z to the 3/5. Number 9. 16 to the 3/2. Well, if we put that in radical form, that would be the square root of 16 cubed. What's the square root of 16? 4.
4.
All right, so then someone do 4 cubed on the calculator for me. 64. Duh, dummy. All right. Technically, on your calculator, you could put 16, do the caret button, parentheses, 3/2, and it'll give you 64 in your calculator. All right. Number 10. I got 6 times t to the 2/3 times t to the 4/3 over t to the 1/3. So that would be 6t to the 6/3 over t to the 1/3. And what is 6/3? 6 to the t squared over t to the 1/3. And then when I divide, what do I do to the exponents? So that'll be 2 minus 1/3, which that will give me 6. Oops, it's not a 6. That'll give me 6t to the 5/3.
Does the exponent
D, oh,
apply to
score
both
100.
6 and t, or does it just apply to
Oh yeah.